Hello, Jeff Zwarenk, and welcome back to Give and Take, the segment of our show where we explore important scientific ideas to help you be more convinced of the truth of Christianity. Today, I'm joined by my friend and colleague, Dr. Fazale Rana, and we are going to be asking the question, did a computer algorithm solve the origin of life problem? Fuzz, it's good to have you here today.
Jeff, thanks for having me.
Looking forward to our conversation. So why don't just kind of get us started, kind of lay out for us, what is the origin of life problem and what is it that people are trying to do here?
Yeah, well, uh, from my perspective, one of the most enduring scientific mysteries is the origin of life question. How did life first come to appear here on Earth? And most people in the scientific community approach this from an evolutionary perspective, where they try to essentially understand how molecules that would be present on the early Earth could, in effect, evolve to generate the very first protocells, with the idea that simple gaseous molecules present in the atmosphere or at hydrothermal vents would react to form more complex molecules that would then begin to aggregate and self-organize into the first protocells that could continue to evolve to give rise to the first cells. And sadly, origin of life researchers can't time travel and go back in time and observe what happened on the early Earth. So their recourse is to go in the lab and to try to recapitulate the different steps that they think could have contributed to chemical evolution and to the origin of life process. And so they try to identify, again, chemical routes that could generate life's building blocks and then have those building blocks combine and organize into more complex structures. So it's called prebiotic chemistry, and that's largely the focus of origin of life research.
So it seems like you've got this problem of taking very relatively primitive chemicals on the early Earth and making them into complex biochemical systems is what life is. That's basically what you're talking about here, correct?
That's exactly right, yes.
Okay, so how does a computer algorithm weigh in on that? Because it seems like that's mainly lab work, if you will.
Yeah, well, the problem is that when you're doing work in the lab, you want it to be relevant to the conditions of the early Earth. You want it to reflect the types of resources that would be present, the types of energy sources. But one of the factors of the early Earth that is very difficult to replicate in the lab is the sheer chemical and physical complexity of the early Earth's environment. And, and so because of that, most researchers simply focus on singular reactions involving a limited number of reactants. And this allows them to identify the different chemical reactions that could have taken place on the early Earth and figure out the mechanism, but it doesn't really, again, replicate the complexity. And so what you really would like to do ideally is have a vat and throw all kinds of chemicals into that vat that you think would have been present on the early Earth and let it react and see what happens. But until recently, we didn't have the ability to truly analyze that kind of an experiment. And now that we do have that ability, it's still impossible to tease out the different individual chemical processes. So in a sense, you're at this stalemate as to how do you best approach studying chemical evolution.
And so presumably what they've gone is they've been able to take and allow the computer to go search those chemical interactions and things that would just be too complex, too time consuming, or too resource intensive to do in the lab?
That's exactly right. So there's a whole push in organic chemistry to do what's called computer assisted organic synthesis, where you essentially have enough of an understanding of how chemistry works that you could develop algorithms that could essentially predict how a chemical reaction is going to transpire. And so what this research team did from the Polish National Academy of Sciences is developed an algorithm called alchemy, where they could essentially model the chemical processes happening under the conditions of the early Earth. And so they developed a set of chemical rules that reflected the chemistry of different functional groups and the conditions of the early Earth. And then they just chose a set of molecules they thought would be reasonably present on the early Earth and let them react. And then once they reacted, they took those products that were produced and combined them with their original materials and let them react again. And they did this for 7 generations or for 7 iterations as a way to try to understand the early stages of chemical evolution.
So tell us some of the things they found. I mean, that sounds pretty fascinating that we can, in some sense, replicate conditions that are no longer accessible on the planet in computers and get insight. What did they find when they did this?
Well, they were able to generate like 37,000 different compounds through 7 iterations, which is mind-boggling. But this again shows you the types of chemical complexity that would be present on the early Earth. And they were able to identify chemical reactions that we've already discovered in prebiotic studies in the lab, which is reassuring. And they even discovered new chemical processes that nobody even thought would exist. And they went in the lab and they verified that those chemical processes would actually produce the types of compounds that their model predicted. But then on top of that, they discovered that of those 37 compounds, only 80 of them were biotic, were of biological significance. 40 of them were peptides, which are molecules made by joining amino acids together. And of those 40 compounds that were remaining, they had a set of properties that distinguished them from all the other 37,000 properties. They were thermodynamically stable. They had a limited number of what are called functional groups. Those functional groups that they did have were generally unreactive. And of the functional groups that were present in the molecule, they displayed a balance in terms of their hydrogen bonding properties. And so these are actually these very types of features that would make those molecules persist under the conditions of the early Earth. But those are also, interestingly enough, the very properties that would make those molecules so useful in a biochemical system, so useful for the cell.
So it sounds like they've really discovered and developed a really cool algorithm, some neat computer processes, found some really fascinating stuff. So in terms of the origin of life issue, does this weigh in a creation, or weigh in favor of creation, or does it weigh in favor of evolution?
Well, I mean, the thing to keep in mind is that this is still a computer model, and I believe that it is a rather sophisticated model that performs reasonably well. But all they did was really model the first steps. They still didn't account for how you would go from these building block materials to more complex biomolecules, or how self-organization would take place. So they're a long way off from solving the origin of life problem. There's also, in my mind, some concerns about, is this truly relevant to the conditions of the early Earth? I won't get into those details. So in some respect, I don't know that they necessarily really explained how chemical evolution could produce the origin of life. But on the other hand, they did find some interesting things that I think strongly suggests a theistic interpretation for the origin of life, regardless of whether you think it's creation or evolution.
So kind of briefly, if you will, what are some of those things that weigh in favor of a design or theistic background for life?
Yeah, well, let's just say for the sake of argument, you assumed that evolution was the way that life emerged, that it was through chemical evolution. What's interesting is that these researchers seemingly discovered that the laws of nature are constructed in such a way that chemical reactions that would have happened on the early Earth are going to produce compounds that would persist, but that also would be biologically useful in a cellular system. So it's almost like the laws of nature have prescribed certain chemical processes that inevitably are leading you to the types of materials you would need for the origin of life. And so to me, this is kind of like an anthropic coincidence, if you will, that suggests that even if you're thinking about the origin of life from an evolutionary perspective, it looks as if things have been jimmy-rigged in such a way to make life possible. And if it's jimmy-rigged in that way, then it suggests that there's a mind behind everything. So whether you approach the origin of life from a creation model perspective or from an evolutionary perspective, you seem to be forced into the same place, that there needs to be a mind that's involved in this process.
Well, thank you very much, Fuzz. I appreciate your comments. You know, when we do look at the origin of life, it is a fascinating, complex, and challenging problem. And it may forever remain, at least in its entirety, outside a scientific understanding. But what I find fascinating about this discovery, as Fuzz highlights, is that as we continue to advance in our understanding of this difficult and complex topic, we still find evidence that points to a mind. You know, I'd encourage you to go to reasons.org and check out Fuzz's blog on this. Have researchers developed a computer algorithm that explains the origin of life? You'll get some great resources that equip you to share the fascinating discoveries we've made about this universe and how they point to a creator who's created us to know him.